So today we're going to learn about Le Chatelier's principle and Q versus K. Q is products over reactants, though not necessarily at equilibrium. And K is also products over reactants, but it's always at equilibrium. So when Q is equal to K, that means that the reaction is at equilibrium. If a reaction is product favored, Q will be greater than K. And if it's reactant favored, Q will be less than K. So one factor that can affect the equilibrium is pressure or volume. These are connected because an increase in pressure is the same as a decrease in the volume of the container, and a decrease in pressure is the same as an increase in volume. When the pressure is decreased or the volume is increased, the reaction will shift, or the equilibrium will shift to favor the side of the reaction with more moles of gas. So we're using the generic equation here, R representing reactants, P representing products, and X just being X, could be anything. This reaction would shift to be product favored, so Q would be greater than K. This reaction, because there are more moles of gas on the product side, Q would be less than K, because the reaction would shift that way.
Yeah, 600.
When pressure increases or the volume of the container decreases, equilibrium will shift to favor the side with fewer moles of gas. In this case, which is the same equation as we had up here, it will shift to be reactant favored, and Q will be less than K. Here it will be the opposite, and the reaction will be product favored, so Q will be greater than K.
She is in this one.
Another factor that affects equilibrium is the concentration of the components of the reaction. Again, using the neutral equation, reactants yields products. An increase in the concentration of the products is the same as if there were a decrease in the concentration of the reactants. So if that happens, the equilibrium will shift to be reactant favored. When the concentration of the products is decreased, it's the same as if the concentration of the reactants is increased, and the equilibrium will shift to be product favored. Another factor that can affect equilibrium is temperature. If the reaction is exothermic, heat is treated as a product. So an increase in temperature has the same effect as if you increase the concentration of a product. The reaction will shift to be product favored, and Q will be greater than K. If the temperature is decreased, the reaction will shift toward the product. Oops, just kidding. If the temperature is increased, that means it's the same as if the concentration of the products were increased, and it becomes reactant favored. So Q is less than K. And if the temperature is decreased, it will become product favored because it will shift to make more heat. If the reaction is endothermic, heat is treated as a reactant. So if the temperature is increased, it means that there's too much over here, so it will shift to the right and be product favored, darker. And if the temperature is decreased, Q will be less than K because the reaction will shift left. So if a solid or an inert gas is added to the system of the equilibrium with no change in volume, that's very important. As long as there's no change in volume, it will have no effect on the equilibrium whatsoever. So a side reaction is when another component enters the equilibrium and reacts with one of the reactants or the products. And when that happens, the molecule that was reacted with gets taken out of the equation. Not the equation, but the system. So if the reactant gets reacted with and therefore taken out, then the equilibrium will shift to make more of it, and Q will be less than K. If the product is taken out, the reaction shift right becomes product favored, and Q is greater than K. Now we're going to work through a practice problem together. We'll be working with the equation PCl3 plus Cl2 yields PCl5. Will Q be less than, greater than, or equal to K when 1. The volume of the container is reduced by a factor of 1/2. If you'll remember, when the volume of the container is reduced, the equilibrium shifts to favor the side that has fewer moles of gas. These are all gaseous. So that would be the product side in this case, which means that Q is greater than K. When neon gas is added, neon is an inert gas, so that will have no effect on the equilibrium. Inert gases are very nice to us. When potassium is added and reacts with the Cl2, that removes the Cl2 from the equation. So we need more, which means that the equilibrium will shift left and favor reactants. Q is less than K. When the concentration of PCl3 is increased, that means we're heavy over here, so it needs to shift to favor the products. Q is greater than K. When temperature is decreased, now we have to look at whether the equation is endo or exothermic. Here, bonds are formed instead of broken, so energy is released, which means that it is exothermic. So that means that when the temperature is decreased, it's the same as taking products out, which means that the reaction will shift right and be product favored. This is another practice problem that you're going to try on your own. What you can do is pause the video and work through it, and then when you're ready to see the answers, unpause. Are these your answers? If so, good job. You learned something from this video. Thanks for